All right, so we're here. So let's do some checking. So I'm zoomed in onto the bias circuit right now. Like I said, this is a 568. I have the 568 schematic. So we're just going to go kind of component by component. We'll start here and then work our way down and see what happens. So luckily, the multimeter that I have lets me measure capacitance. So since this multimeter lets me measure capacitance, we're just going to check the cap first. All right, so if it is original, you can see it's 50 over 70 volts, rated for 70 volts. So what we actually have is, assuming that the voltage rating hasn't changed, then we actually have a 111.9 microfarad instead of 50. So that might be a problem, since we've doubled our capacitance. Let's just check the resistor, which is coming off of the transformer, and then it's getting rectified by this diode. Okay, so that actually looks fine. So this is a 1K resistor, and this is only 1.005K ohms. So it looks like the bias circuit, I think that filter cap's bad. So what we'll do is we'll replace this to turn it into an AB763. What we want to actually put there, the original had a 25 over 50, rated for 50 volts. So we're going to change the capacitor out. And we're going to turn this into a, I think I was only able to find a 33 microfarad at 450 volt rating. I don't think the rating matters. I think for this circuit, the most we'll see is around 50 volts because the power delivery, or the voltage delivery, is 51 volts over here on the other end of the bias pot anyway. That'll be the first change. So it looks like I was partially right, at least that cap is bad. So let's check the downstream components. And see what happens. So I know there's a 10K linear on both the 763 and the 568. So I'm not going to check that pot. I think that pot was fine. But I'll check the tree of resistors that come after it. So those are two 10Ks off of the bottom and top lugs. So let's take a look. All right, so the top lug is 6.9 nice ohms. Oops, do that one in red. And then let's check the bottom one. It's the same, 6.9, 2 ohms. So it looks like they are matched. I think the banding is 10K. So the resistors have the banding that they're 10K, but the actual resistance is a lot less, 30% less. So the resistors are bad as well. And let's just check the 15K to ground bias limit resistor. So that one's actually okay. That one's at 15.16 ohms. There. Believe the 763 circuit had a 27 to ground as kind of the lower limit bias. So then let's check this 100K after the two trees that's feeding into the 6L6s, or one of the 6L6s. All right, and that one is 108K. Okay, so those parallel resistors are bad, but the 100K is okay. That's within 10%. So then let's move down into the caps here. There's a little bias circuit that feeds the 6L6s, and then the inverter as well. So, like I said, in the 763, there's actually a branch here that has another resistor here, and then I believe it's 100 here, and then 80 here, I think. I can't remember. We'll take a look. But for this 568 circuit, it's actually just, they're split up. So the wiper goes to this inverter as well as the 606, and then these parallel tree into the 100K feeds the 606. So let's take a look at what the resistors are in that little tree there. And I already looked at the caps. They are both 0.1 microfarad, just like it says, but we'll check the capacitance to see what the actual value is. So, all right, so my right is 51.7, 51.7 ohms, kilo ohms, Actually, we'll just write this down lower. 51.7K ohm for this guy. And then let's check the left. 50.7. K ohms for this guy. So they definitely drifted. Those have a silver band, so they're 10% tolerance. So one of them for sure is bad. The other one's within its tolerance. But the other one's drifted a little bit over 10%. So let's go ahead and look at this 100K feeding the 1287 inverter tube. Alright, so that guy is 106.9. Nice. Okay. Ohms for that guy. And then let's look at the capacitance for the left tree first, since that one, it doesn't matter. We'll take a look at that one first. Alright, so that's 100 nanofarads, or 0.1 microfarads. So that one's okay. And then let's check the right one. And that one is 102 nanofarads. And that's again 0.1 micro. And that makes sense. The caps on the board were all changed out, so those shouldn't be a problem. But the bias circuit one was left alone, and so that one looks original. So this guy will be changed. And then we're going to actually tear out most of the circuit on the right post pot. So the 10K linear is the same between the 763 and the 568. The resistor to ground for the minimum bias is 27. I think it's 27 at least. It's definitely higher than 15. Yeah, 27K. So that will be grounded as well. And then we'll change all of the B plus lines as well. The doghouse filter caps were all changed, so those are new, and they look like they're the right values. But the wiring was done a little sketchy, so we'll probably look at that and just see what happens. Down there, the circuit proper on top, like I said, we're going to pull out most of this. I have parts ordered, so whenever they come in, we'll go ahead and put those in. But I just wanted to walk through the circuit just to check what the actual values are, to see what the drift was, and see if my gut reaction to the bias circuit was right. I think it is. I think that filter cap that cleans up the rectified AC to DC current or voltage is either leaky or something's happening, and potentially that's what caused that one tube to light up. I thankfully bought new 6L6 GCs, Mesa Boogies. I don't know if that's going to show up. So I have a matched pair that I bought, and we'll go ahead and see if they light up again, and then I have to buy another pair, or if we're good. So let me go back to video on the iPhone, and after we've taken out these components, and then we'll put a game plan together for what else we need to do. I forgot to record this. I'm doing it in post. I did the islet board like you saw in the time lapse. Took out the capacitor. It was a Mallory. It looked original. We already checked the capacitance, so we knew it was bad. I have parts coming in the mail, so hopefully end of this week or next week we'll get the parts in, and then we can finish rewiring the bias circuit. So I'll probably do the same thing. I'll have a time lapse of me putting the parts in, and we'll do a tone check at the end to see what it sounds like. I may walk through biasing. I may not. I don't know. It's helpful to not have a lot of moving parts, and I knocked my phone down like 5 times recording, just taking the parts out. So I don't think running high voltage and knocking my phone in will be a good idea, but we'll see. I don't know. So stay tuned for that. Hopefully the next video will be the last one and everything will work. So see you then. Thanks.